All right, so for this online lesson, we're sticking with right triangles, but we're going to be discussing special right triangles. And perhaps you've seen of these or heard of these before, but they're special not because they're right triangles, but what makes them special is the angles that are inside of them. Okay, so let me draw my best triangle here, make my best attempt. That's a good looking triangle. Okay, so it's a right triangle. And what if I told you that this angle was 45 degrees? Okay, with just that information, without doing any math, I know what the other angle is and I know what all three sides are. Now I know what you're thinking. Well, Mr. Schwann, of course we know that all the angles inside of a triangle equal 180 degrees. So 90 plus 45 is 135. 135 minus 180 is 45. Duh, Mr. Schwann, anyone could find the angle. But there's no way you can find the sides because you would need Pythagorean theorem, right? Because you need to have two sides and have a third side. And I can't even do trigonometry because I don't even know one side. I know nothing about the sides. But yet, I know that these are the numbers. Okay? Now, remember when I said about trigonometry that the reason we have sine, cosine, and tangent is that because in a right triangle, the ratios have already been set. Because all right triangles are proportionate to each other, the ratio between sine, cosine, and tangent with the angle on the sides has already been determined, and that is why we're able to use sine, cosine, and tangent in the calculator, because that ratio or that scale factor has already been set. Okay? And it's the same thing, but now we're dealing with these specific triangles, this one being called a 45, 45, 90. I bet you can guess why, because, well, look. 45, 45, 90, right? That's the angles, and that's where we get those names from, okay? And I know, based on those, that those are the side lengths. Now, they won't always be these numbers, but make the assumption, if I tell me the sides of a 45, 45, 90 triangle, this is what you'd write down. In fact, if you're taking notes, I'd recommend you write this down and memorize it because it'll be super, super helpful, okay? Now, you'll also notice that, again, opening from the 45-degree side is 1, and opening from this 45-degree side is 1, right? So the sides that open up to the 45-degree angles, they should be the same, right? Because of the same angles. But notice how the hypotenuse is the biggest side, right? And that's still true, because the square root of 2 would be about I think it's 1.3 or 1.4 if you type it on the calculator. Okay? So, for this triangle, again, if I give you no sides, the preset sides are 1, 1, square root of 2. So let's say I give you a triangle that I already give you the sides, okay? So let's say I do this. So this one's a little bit bigger, but I tell you that this is 90, and I tell you that this up here is 45 degrees, okay? And let's say I tell you that this side length is 3, and that's all I tell you, okay? Well, the first thing you should be able to do is, well, Mr. Schwann, if that angle's 45 and the bottom angle's 90, or the right angle, that means this is 45. Okay, that makes sense. All right, and then you should be able to say, well, I know that the 45-degree angle sides need to match, so this side will be 3. Okay. So, but how do I get to this side? How do I know what this side is right here? How do I know what the hypotenuse is? Okay. Well, what we do is we use the scale factor. Yes, remember when we did scale factors from before? That is exactly what we do here, okay? So I go from, you could go small to big, big to small, whatever you want. But again, you got to pick matching sides, okay? So I'm going to do small to big, so 1 to 3, okay? So from 1 to 3, it equals the square root of 2 to x. So I guess I'll call that x because I don't know what it is. Okay, so I set up a scale factor, just like what we did before, okay? And now I need to solve for this proportion, okay? Now, here's the tricky thing. On the instructions for most of these, it will tell you you cannot use decimals. It says leave your answer as a radical, okay? So here's what you do. We still cross multiply, so 1 times x and 3 times radical 2, okay? So 1 times x equals x. Okay, and 3 times radical 2. Well, I really can't multiply those together, so I'll just stick them next to each other. So there we go. So that actually equals 3 radical 2. So that's what that missing side is of that triangle. Okay? So again, all you do is set up a scale factor, just like what you've done in the past before, but you have to memorize the original triangle, where the 45-degree sides are 1 and the hypotenuse is radical 2. You have to know that and memorize that. Okay? In fact, that's going to be a quiz question coming up. Shh. Secret. All right. So let me give you one more example of 45, 45, 90 here. Okay? Let me give you one more example here. So, let's say I have this triangle. Okay? And I tell you this is 90, this is 45, and this side is 7. Sure, we'll call that 7. Okay, so the hypotenuse is 7. Okay, well, the first thing I'm going to do before I do anything is draw the original 45, 45, 90 triangle, right? Often duplicated, never repeated, I guess is the best way to say it. So often mimic, never truly repeated. There you go. So the two sides are 1 and the hypotenuse is radical 2. Okay? So that's my original triangle, and now I got to set up a scale factor. So the hypotenuses go together. So I'll do, they look like the same size, but I'll go left to right. So 7 over radical 2 equals, again, we'll call this x, sure, x over 1, right? Okay, so what we do is we cross multiply. So 7 times 1 is 7. Okay, so 7 equals, and then radical 2 times x is just radical 2, x. Okay, and to get x by itself, we have to divide by radical 2. Okay, but there's this weird thing that I can't leave my answer like this. I can't leave my answer x equals 7 over radical 2. Okay? The reason why is because I can't leave radicals in the denominator. Just like how I can't leave zeros in the denominator that makes it undefined. Sort of the same idea. I can't leave a radical in the denominator. So, in order to solve this correctly, it's actually really simple. I'll teach you the actual mathematics of it here. But the shortcut would be move the radical up to top. Okay, so 7 radical 2 is on top. Okay. But then, whatever's inside the radical, leave it on the bottom. So my final answer for x is 7 radical 2 over 2. Okay? So, again, I'll get into another video and explain, hopefully you've seen rationalizing denominators before. If you haven't, that's okay. I'll show you in class, or you can watch one of my other videos where I outline it. But the shortcut is you move the radical to the top, and whatever's inside the radical, copy it on the bottom. And so that is what x is. So x is 7 radical 2 over 2. And so if this side is radical 7 over 2 over 2, this side is also 7 radical 2 over 2. Okay? And that's how you do it for a 45, 45, 90 degree triangle. Okay? In my next slide, I'm going to do it for a 30, 60, 90 triangle. But this is how you solve a 45, 45, 90 triangle.